All right, looks like everybody's made it in. So welcome. Welcome to ONIG webinars. Today I am talking with Zscaler on zero trust segmentation, or why identity is key to stopping attacks. Before we jump in, just a little bit of housekeeping. First and foremost, for questions, please use the Q&A button at the bottom of your screen, not the chat, the Q&A. That'll guarantee that we see it and we can get those questions answered. In just a second, I'm going to set the stage with some background insight into what's going on in the zero trust world. But before that, I'd like to go ahead and introduce Frank. Frank is I was going to say senior systems engineer, Frank, but I've got that wrong. Why don't you go ahead and introduce yourself, and you'll get it right.
Hi, everybody. I'm Frank Dagenhardt. I'm a solutions architect for Zscaler in our cloud segmentation product, and have a long history in segmentation. Have even written books on the subject. So appreciate being here today to talk to you guys.
And Frank and I were just talking about how incredibly timely it is to think about segmentation because, speed of light failures and attacks, such as what happened with Facebook, show that what worked before is not actually working today. So Frank, if you don't mind, just go ahead and click forward to the starter slide. Okay. So I'm just going to set the big picture for everyone, which is this is all in the broader context of zero trust. I'm trusting that most of you know what zero trust is, but not everyone knows why folks are implementing it, how folks are implementing it, and whether folks are implementing it. So just to give the broader perspective, companies have started to realize that zero trust is the answer to an awful lot of network security and cybersecurity problems generally, but it's a challenge to figure out what to do first, second, and third to get it started. So here's some of our research from a recently conducted research study. What we found is that companies that are successful are 138% more likely to be doing zero trust. So that means that people that are organizations that have a low serious incident per incident account, that is the serious security incident per total security incidents of 2% or lower, are more likely to be doing zero trust. So there's a correlation, not necessarily a causation, but we can infer that the causation goes zero trust to reducing the CIPI, which is a metric that we look at as a good quick hit way to gauge how effective somebody's cybersecurity stance is. We also found that when they are implementing zero trust, successful companies are 110% more likely to start with developing the architecture. And that's what makes Frank's presentation so incredibly relevant, because what's interesting is for many of us who come from a cybersecurity background, you don't want to start with the architecture, you want to start with the policy. And interestingly enough, policies really happen at phase 3 of a zero trust initiative in the successful organizations. So basically, if you're trying to put together a zero trust roadmap, start by planning to develop the architecture. Then in phase 2, rethink your data architecture, your network architecture, your firewall architecture, and additional architectures in light of your zero trust architecture. In a sense, start with your to-be design and then look at the changes that have to be made on your as-is design, and then gear up to put together the implementation team, think about what's going on in the endpoints, think about how the applications are going to need to be changed, buy any additional tools that you need, and do policy revisions in that phase 3. So really the right plan of attack is build your architecture, rejigger your current architecture to align with that new zero trust architecture, and then begin with the policies and application alignment. And so on that point, Frank, maybe you want to click to the next slide and start talking about an identity-based architecture for zero trust.
Absolutely. Thank you very much. So I think it was outlined pretty clearly that zero trust is a very important part of the future in securing not only your workloads as they sit in your hybrid cloud environment, whether that's on-premise in the data center, in a colo, or across multiple cloud vendors, but traditional forms of security like firewalling or castle and moat type security aren't able to handle today's level of sophisticated attacks. And above and beyond that, our applications have changed, right? They used to be 80% north to south and 20% east to west traffic. Now they're distributed and virtual and even containerized, and now they're 80% east to west traffic and 20% north to south. So what we found is that in today's application architectures is that traditional segmentation allows for way too many attack paths. So what we're seeing in customer environments across the board is that on average about 97% of the allowed network paths to the applications are actually unused. So while less security is definitely easier to manage environment in some cases, the amount of attack paths that we're providing are just really open season for things like ransomware and other things inside of customer environments. So, part of the problem is that we need to rethink how we're going to secure these environments. But the other part of the problem is that in order to secure your applications, you really have to understand your applications. You have to know what's normal traffic and what might not be normal traffic. Because if you're going to create a zero trust environment where we're only allowing the good traffic and blocking all the bad traffic, we have to know what that good traffic is. And so traditionally, this has been an issue for environments is, maybe the people that installed the application don't work there anymore. Maybe you acquired an application, maybe it's been upgraded many times since or moved to the cloud. But traditionally, this, fact gathering process of inventorying the network, collecting the data, analyzing it, building segments, building policies, so on and so forth, and even deploying the policies. By the time you get to deploying the policies, your policies are already out of date, right? Because from that perspective, your applications may have changed many times since. Above and beyond that, we found that the data that's collected a lot of times isn't accurate from that perspective. And now that you have this zero trust environment in place, we also need to make sure that the policies are updated and stay up to date, right? Because now these are living and breathing policies that need to change when your applications change inside your environment. And so the traditional way that we've done this in the past has been ineffective. And not only from a implementation and a return on investment standpoint, many people start going down this road but never quite get there because they hit an application that they don't understand as well. And then they can't come up with the policies and can't profile it and can't secure it. But also what we found is that the technologies that we're using to secure these applications don't work or don't protect your environment well enough against today's modern attacks, because they're actually just allowing traffic to go through based on a assumption that the traffic is good. If it's coming from this IP address and going to this other IP address on this port, then it must be, for instance, web traffic, and we're going to allow it to go through. And that's exactly how things like ransomware propagate through your environment, is they can actually piggyback over those protocols and over those IP addresses that are allowed through your environment, even though you feel like you're somewhat segmented inside of your environment. So from a Zscaler perspective, we're changing the ways that we look at segmentation. We're moving away from address-based legacy security controls based on port and IP address to security that is actually identity-based. And Gartner themselves have said that really identity-based segmentation should be the core protection strategy for your workloads. And the reason is because identity is paramount. If you go to the airport and you go up to the TSA and you were to try to get through the TSA just by saying, my name is Frank and I'm from Michigan and I'm going to go to Raleigh-Durham Airport, they wouldn't allow you to go through, right? Because that's not identity, just telling them who you are and who you're supposed to be and where you're going. They want to see your driver's license, they want to see your ticket, right? They need to verify multiple attributes of your identity. And that identity is verified again and again as you go from one security checkpoint to another. It's not just verified once and then you're good every time you fly after that, right? When I fly back, it's going to be identified again. And we need to be doing the same thing for our applications. And so, from that perspective, that's the standpoint that we're taking from a segmentation standpoint. We are verifying the identity of the applications running your environment. And as we kind of discuss some of the technologies, we're going to talk about how we only allow approved applications to talk to other approved applications, and only if your policy allows it, right? And only if they remain unchanged and their identity stays unchanged. Just like when you walk up to your business and your badge to go in, they know who you are, they allow you into the business. If you try to go into another room where you're not allowed, you scan your badge, it's going to be denied, right, from that perspective. So from that perspective, we're advocating for this identity-based level of segmentation, where we not only use the identity to understand the applications, understand what is normal for those applications and how they communicate, but then also develop our policies based on those application identities so that we know if they change in a malicious way, we can stop an attacker, but also be able to know which application should be allowed to which application, to talk to which applications, and only allow that good traffic to go through. And obviously, based on today's technologies, we want to make that as easy as possible for you. So we want to do about 90% of the work for you, so that you only have to do about 10% of the work, and you're able to actually get to the segmentation you're planning on enforcing in your environment, but also maintain that as it goes forward. So the system itself is built on machine learning and a big data analytics platform, where we make it very easy to deploy the system because it's built on software, and you can literally deploy the software in your environments in minutes. As soon as you deploy that software, the system starts listening to your applications communicating with each other. We then recommend how you should segment your environment to become more secure. We also recommend the policies that you should put in place to only allow the good traffic and deny all the bad traffic. And then on top of that, we don't just take those policies, put them in place. We want to simulate those policies. We want to build that confidence. We want to know what the expected outcome is going to be, so that when we enforce those policies, you get only what you intended to get, which is a secure environment, and not any black eyes because a application or critical application doesn't work anymore because you blocked some of the good traffic from that perspective. So let's talk a little bit about some of the technology. As I mentioned before, we wanted the system to be delivered in a cloud format and as a service. We wanted to do all the care and feeding for the system, so you didn't have to. You didn't have to support it from a power, cooling perspective. You didn't have to do any upgrades. So we basically spin up a portal for you. You log into that portal either through the console or through a REST-based API. And then you download an agent, and that agent is actually installed in the operating system. And that agent's what gives us that really interesting perspective of seeing into the application, as well as being able to apply security as close to the application as possible. Now we send our visibility information up to the cloud recommends policies, send those policies back down. And once those policies are being enforced on the agent, at that point, we can make all the decisions locally. So if for some reason you lost connection with the cloud, the system still runs just like it should, enforces your policies just like it should. And then when it comes back up, you have the ability to change policies. But this is a software agent-based system, and is what gives us that unique perspective. It also gives us a ton of portability, because it doesn't matter what your underlying network architecture is. It doesn't matter what your underlying virtualization architecture is. And we can support any cloud vendor and even containers from that perspective. So it's a very modular system, and you get the same level of visibility and the same level of control, no matter where you deploy the system or where your workloads reside. Now, on top of that, we also want to integrate into your current security administration tools. So we're going to send our information out to things like your SIM system for monitoring and logging. Most of our customers set that up so that if they see, for instance, so many blocks come in for some reason, right? Maybe there's something happening you should know about. We launch a ticket, and then you come to the console and administer it. But we're not going to completely change the way you manage your security operations just because we're bringing this capability into your system. We're going to allow you to use your current tools and things that you've invested in to monitor the system as well. So as I mentioned, what's really different about our system is that we actually don't use the host-based firewall, which a lot of systems do out there today that are trying to provide segmentation. What we do is we tie into the applications, we listen to the applications. We also inventory those applications, and we do that through our machine learning and our policy automation engine. And so just like when I go through the TSA and they ask me for my driver's license, right, we're building that identity for each individual application that is running on your workloads in your environment. So every different application gets this identity built. This identity is built on not one attribute, but 31 different pieces of information, right? So we can get a really clear picture of what that application is, who it's communicating with, and what it does normally. But it also comes in very important when we want to be able to detect things like, is it a malicious piece of software? So we take all these fingerprints and we compare them to Zscaler's threat feeds. And we make sure that if you have current software in your environment that may be malicious, that we don't allow it to keep living in your environment. We actually leave it out of our policies. And because you're building that zero trust environment, if it doesn't have a policy, it will be basically not allowed to communicate anymore. And we would also send you a threat alert on that to say, hey, we see some malicious software here, you should know about it, but don't worry, we left it out of our policies. So you're good to go from that perspective. The other aspect is that we also want to know when things like upgrades happen in the environment, and we'll talk a little bit about that as well. But what we do is we build these independent fingerprints on an application by application basis, and then we recommend policies to only allow these known good applications to talk to each other. So our policy, for instance, looks like usermanager.jar is allowed to talk to my SQL server. And that's a lot different than a firewall policy, right? A firewall policy would be this IP address can talk to this IP address on 1336. And as long as it looks like that, you're good to go. In this case, we're verifying the identity of the application with every connection that is made. And in this case as well, you can see that it says usermanager.jar. So in the case of things like Python and Ruby and Java, for instance, it's not good enough just to say, okay, Java, you can run whatever you want, right? There's a lot of different Java jar files you could run with that process. So in this case, we're getting the identity down to the sub-process to say you can only run these specific Python scripts or these specific Java jar files. And if your identity checks out, you're allowed to have that communication. So that's another big difference, is this is actually pre-connection validation. So a firewall usually watches packets that go back and forth, and if it sees something bad, it stops it, right? But from this perspective, what we're saying is before you even make the network connection, we're going to make sure you are who you say you are and you're talking to who you should be talking to. And then we're going to allow the communication to go through, or we're going to allow it to be denied, right? So you don't even get access to the network unless your identity checks out. And finally, if somebody was to modify the identity here and try to use it for bad things, the fingerprint is going to change. And if it changes for a bad reason, it's going to fall out of the policy because our policies are tied to that fingerprint, and there's going to no longer be allowed to communicate in the environment. So it's a very granular, very powerful level of security. But the best part about this is that it's actually much more resource efficient on the actual servers themselves, because you're probably thinking, wow, this granular level of security is going to really take a lot of horsepower in my environment. But it's also very easy to implement because the machine does 90% of the work for you. So in most cases, we can provide our segmentation much more quickly than other solutions out there, usually in about half the time, but we're also going to a much more granular level. So you kind of get the best of both worlds from that perspective. And we'll talk a little bit about that. So if we look at how we do our enforcement, as I mentioned, we do that through an agent. It is an agent that interacts with the kernel, and we use an API to interact with the Linux security module and the Windows filtering platform. Now, basically what we do is most other solutions out there, right, they interact with that LSM and WFP, and they kind of take a right turn to go to the firewall. What we're doing is actually taking a left turn to go to the application. So what we do is subscribe to 6 different system calls out there. And when the application uses one of those 6 different system calls, like open, bind, listen, connect, exact, or socket, those are system calls they use to access the network. And when they're accessing the network, we kind of get in the middle and say, hey, you know, what's your identity? And if it matches and is correct, the best part about it is we allow the connection to go through, and then we completely get out of the way. So we don't have to sit there and monitor every packet going back and forth, which is very resource intensive. We actually just monitor that initial pre-connection and then allow it to either go through or not, and then completely get out of the way. And that's why you see some of the resource consumption statistics that you see on the left here. You know, 5 microseconds of latency, where a normal firewall is about 120 to 150 microseconds of latency. Less than 1% of one CPU core, not adjusted across all the CPUs. You know, the memory, the bandwidth here, you can see 20 kilobytes per hour is almost nothing. And in most cases, when I'm working with customers on this, I'll be working with high profile, high performance applications, and they'll be like, okay, before we put this in production, we really want to test this and make sure, you know, what you say is true. So, you know, we're going to have our guy get on the system, you're going to get on your system, we're going to turn it on and have them look at all the resource consumption, and we'll see exactly what it is. So, you know, go ahead, turn it on. And I'll have to tell them that it's been on for like 5 minutes already. They can't tell the difference. They've never, you know, they haven't seen it. So it's actually pretty funny from that perspective. But, you know, I guess a piece of information here, just to make sure everybody's on the same page, is that as you can see, we support Linux kernel 2.6 and above, and Windows 2008 R2 and above today. And we're going to have some additional support for some proprietary operating systems. But for the most part, we support about 90% of the open operating systems in the environment. There's always going to be some stuff we don't support. And that's true with any agent-based segmentation solution out there, not just us. But because those systems without an agent do talk to systems with an agent, normally we can still control half of that conversation. So as a device without an agent interacts with a device with an agent, we can still apply our security. Or as a device with an agent reaches out to one without it, we can still apply a level of security. And once again, we're still going down to that application level, so much more granular than what a lot of folks do out there. And the agent's also very easy to install, never requires any reboot whatsoever, so completely hitless from that perspective. Upgrades, removal, install, you know, no reboots from that perspective. And because we don't interact with that firewall, we have much less dependencies than a lot of other solutions out there, because you have to worry about changing your group policy. You don't have to worry about, you know, too many cooks in the kitchen trying to administer that firewall and who takes priority. So, you know, from the system perspective, one of the things I love is that, you know, because of our architecture, and because it's actually much simpler than a lot of other architectures out there, we can actually get to policies much more quickly. So because we're looking right at the application, because we understand the application and what the application's doing, our policies are very simple. They're basically, you know, SSH is allowed to talk to SSHD. You know, that Java jar is allowed to talk to MySQL, right? Those are our policies. They're very simple, kind of one-line policies. Whereas when you're trying to take an application and convert it to firewall speak, you have to come up with, you know, 10, 20, 50 policies just to define one application. It has to be these IP addresses are allowed to talk to these other IP addresses on port 80 and port 443 and so on and so forth. And if you use dynamic ports, right, you have to open 10,000 through 15,000. That's a huge problem as well. We don't have to do any of that. And because of that, because our policies are very simple, because we're looking right into the applications, we can get to our policies very quickly. And as you can see here, 3 days from not knowing anything about your environment to, you know, we deploy the agent, and within 72 hours, we can come up with our first set of policies. it's almost unheard of. I have a lot of experience with firewall solutions in the past, and it would take weeks, if not months, to get to some of these policies because you have to see every port that it's ever going to talk on. In this case, we define our policies very quickly. We put them into that simulate mode. But once again, once we're done with that simulate mode, which usually takes about a week and a half, so a total time of the machine watching the application of about 2 weeks. In that time frame, we usually get to a point where we can enforce our policy, go through full user acceptance testing, even red team tests, and I'll talk about one of those in a minute. But here's the interesting part is that 25% reduction in policy in policies, 25 time reduction in policies. So when I used to do firewall-based policies, I'd look at an application and I'd be lucky to get that application under about 100 policies. When we profile an application, we're looking at 5 to 10 policies. So if you think about, bringing a zero trust system or a segmentation system into your environment, you still have to do about 10% of the work, right? So 10% of approving 100 policies versus 5 policies, troubleshooting 100 policies versus 5 policies, updating 100 policies versus 5 policies. All this stuff relates into kind of care and feeding and operationalizing, and being successful with a segmentation product. And we've already thought way ahead and done all the work for you there. So by having this, many fewer policies, it actually makes you can actually get a better ROI out of the system, get to segmentation, like I said, in some cases 2 to 3 times faster than you could in the past. But on top of that, when we get to segmentation, we've also thought about what does it take to keep those policies up to date. So once you get to segmentation, as I mentioned before, it's a living and breathing thing. You have to update your policies when you upgrade your applications, and you have to update your policies when you deploy new applications into your environment. And that's one thing that a lot of vendors don't think about, right? They're concentrating so hard on getting you to segmentation. Sometimes it's just as hard to maintain that segmentation when you have it in place. And so what we do, which is really cool, is we take half of this burden away. And the reason is because of our architecture lets us understand those applications. So when you upgrade an application, we compare the fingerprint before and after the upgrade, and we can automatically detect an upgrade. And so when we automatically detect that upgrade, because the fingerprint changed very little, it's still acting the same, it's still running in the same directory, it still has the same signer of the code, maybe it's close to the same site, it's interacting with the same scripts, or it's interacting with the same neighbors. All the behaviors and everything are the same. And when you look across all those 31 attributes, it's actually changed maybe 2 or 3%. So we can actually consider that to be an upgrade. And what we do is say, okay, we're going to similarity match those 2 applications, and we're going to grandfather this new application into your old policy. Because it's still, for instance, if I upgrade my SQL server, it's still my SQL server. The same policy should apply. It's just a new version of the code. And that's way different than any other vendor out there because they don't understand that identity. They actually have to redo their policies because a new version of a new app may talk on different ports or protocols. And there's really no way to know that without reprofiling the application. So from that perspective, we can take about half of that operational overhead going forward away. And now you're only worried about deploying new applications in your environment. And usually once customers start bringing zero trust into their environment, they develop processes around that, right? Every new server has an agent on it. While that application is in development, we're going to profile it. And then when we're ready to promote it to production, we're going to be ready for it and have our policies ready so we can just go ahead and move it into production. So, we've done a lot of thinking ahead in those cases where a lot of other vendors haven't. And we're really proud to say that the majority of our customers that adopt zero trust for their applications in their environment actually don't have to bring on any extra FTEs. So, you know, that's something that we're really proud to say that not a lot of vendors can say out there. So just to kind of rehash this, right? The system automatically helps you build segments for your environment. It helps you create the policies, but then it also makes those segments what we call auto scaling. So as you add servers and remove servers, they automatically match a query, they get put into a group, and they inherit policies. So if I add a new backup server, I don't have to do anything. It just, you know, the system senses it, puts it in the right group, and it inherits its policies. We automatically detect the upgrading of applications, and now really all you're worried about is deploying the new applications, which, as I mentioned, most companies have to, you know, that's just a factor of zero trust. You have to, you know, now build that into your new processes. Now, this is something that, even though you know I've talked about it quite a bit, I like to kind of just put some numbers next to it because it's really hard to understand unless you've been there. And so by us kind of automatically detecting the upgrade, it's like having that easy pass in your car that you drive right through, right? We know your identity, we'll send you the toll, right? Having to update your every application or reprofile every application when it upgrades is one thing when it's 1 or 2 apps, but most companies have, you know, 200 apps, right, or 300 apps. And so if every app takes 20 minutes and you have 200 apps, you're looking at potentially, you know, weeks worth of work. And that's where those additional FTEs come in, and we completely, you know, do away with that from that perspective. So, you know, one of the things that I like to talk about as well is that, you know, this level of security is really what's required to address things like ransomware in your environment. So I'll give you an example of a red team test that I just had a customer do. They had 2 different systems. They had our system in there, our segmentation system, and another vendor's segmentation system. The other vendor was based off of a host-based firewall. We were doing our application identity. So the red teams attacked the system that had the other vendor's version of segmentation in place. They were able to get on the system through a vulnerability, through Nginx vulnerability. They got on the system, escalated their privileges to admin. Now that they had godlike power, they went ahead and created a new application. They used that application that they created with Notepad, which I thought was pretty ingenious. They created it with Notepad. They used that new application to scan for open ports and protocols. And of course, there were some because it needs to talk to other things in your environment like AD and whatnot. And use that to move on to the next system and just do the same thing over again. And so they then ran that same test on our system. And sure enough, they were able to get on the system through Nginx because Nginx was allowed to be communicated with, and it had that vulnerability. So they got on there, updated their privileges to admin. But now when they created that new piece of software with Notepad, we assigned it a fingerprint. And so now they tried to do that same scan with that piece of software, but there was no policy tied to that software. And so it wasn't allowed to make any outgoing connections, wasn't allowed to receive any incoming connections, and it was basically dead in the water. But it didn't just stop there. They actually tried to use an existing piece of software that was making connections and modify that. And when they modified it, the fingerprint changed. The policy no longer fit for that new fingerprint. And that piece of software that was able to communicate was no longer able to communicate. And they ended up going with our system because we were the only ones that could actually stop an advanced ransomware attack. So much like you see in this slide here, right? We're only allowing the good software, the software we can verify, potentially the upgraded software, but anything that we see as bad, right, we're not going to allow. And if that fingerprint changes, it falls out of the policy. And that's another thing that people ask all the time. You know, I have problems in my environment with keeping policies up to date, but I also have problems with old stale policies, right? What happens if a developer goes in and turns off an application? Maybe I'm still allowing port 80 traffic there, but there's no, there's no web server running anymore. In our case, our policies are tied directly to that application. So once, IAS or Nginx goes away, so does our policy, and you don't have to worry about that old stale policy anymore. So it kind of creates good security hygiene as well from that perspective. And obviously we have all of the, dashboards, monitoring, and other things as well that you would expect in enterprise class security solution. So we're seeing many customers use this solution for secure cloud transformation. Customers that are already looking to move to the cloud, or already in the cloud and looking to move across multiple clouds. They want the same level of security for their cloud environment, or maybe they have that level of security in their cloud environment. They want it for their on-premise environment as well. Obviously, zero trust security, not only in the data center, but our solution works as well with our other Zscaler solutions for private access and our internet access solution as well. So they work together, and you kind of get the 1 + 1 + 1 = 4 instead of 3. And then we have a lot of different customers that are using it for security audit and compliance. So we have a lot of customers that come to us and say, hey, we're being audited regularly due to compliance reasons. And right now, everything is in bounds because everything can kind of touch everything else. So when I go through the audit, I have to supply information on pretty much my entire environment. Business stops until my new projects stop until I answer this audit, and then we can kind of resume our life again. So by kind of shrinking the area of creating that segmented environment and shrinking what different applications can touch, they also shrink the size of their audit and can get through the audits more quickly and be able to resume working on projects that actually make the business better, or some of the initiatives. So with that, I think that's the majority of information I had from that perspective. Were there any questions that we came in that we wanted to discuss?
Yeah, there are some great questions, and that was a great overview, Frank. The first one, I know it's going to be tough. You're going to have to really try hard, but I want you to do your best to answer it. Are you really from Michigan?
Yes, absolutely. I'm actually in, the reason I use the TSA use case today is I'm actually in North Carolina today. But yeah, I've been in Michigan my whole life. And even though when I travel, I see a lot of, wonderful things out there. Most of my family's in Michigan, so we always end up coming back.
It's funny because I picked up on your accent, but I wouldn't have picked Michigan. So I had to ask. We have a bunch of great questions. There are a couple that I'm actually going to converge into one. Terry is asking a number of questions about essentially how you avoid classifying malware as a functional application. So his first question was, what prevents Zscaler from learning that existing malware should be allowed? And then he goes on later to ask, do you get false positives? Well, actually, that's the opposite direction. How do you get false positives? So hold that thought. But there's just really this question about when you talk about fingerprinting, how do you avoid positively fingerprinting malware?
Yeah, so that's there's a number of different things. The very first one is obviously Zscaler is a security company, and we are we are constantly updating our threat feeds and get updates throughout the day from both our internal teams and external feeds as well. And so every fingerprint is compared to those threat feeds, first of all. And so if there's a known signature for it, we alert you on it, and we will not include it in our policy. So that takes, that's most of the, everything but kind of a day zero type of issue. The other thing too is that when we develop our policies, we're looking, we have different algorithms built in to look for things that look like anomalous communication and leave that out. So, half open connections and scans and different things like that, right? We're really looking for, what's normal and what's not. And while it sounds like, I don't want to trivialize it, but while it sounds like a hard job to kind of figure out what's normal for a server is a lot different than a workstation, right? A workstation runs anything you download to it at the current day, and you interact with, all kinds of different stuff all day long, whether that's Office or website or whatever. Servers do the same thing over and over again, 10,000 times a day, and they try to run as small footprint as possible, right? So down to 15, usually on average what I see is about 15 to 20 processes, but they're this server's job, for instance, this app server's job is to interact with the database server, and it probably does it 10,000 times a day. So, applying machine learning to that, what you start to see very quickly is you see what's normal and what might be abnormal very quickly. So first thing is the threat feeds. The second thing is, servers are great candidates for the machine learning piece, and just by the jobs and the role that they did. But, there's also that 10% of overhead that comes, right? So it does 90% of the work for you. We try to really filter out, all the false positives before we come to a policy. And then you provide that 10% of oversight. And the great part is that you're only looking at those 5 to 6, policies. So it's really hard for something to slip through the cracks versus if you're looking at 100 or 150 policies, right? And on top of that, you don't have to go back and reverse engineer what port or what software you think it is. We actually tell you. We tell you this is, should curl be doing, talking to this IP address? And if you look at that and that raises an eyebrow, then leave it out of the policy and, let's watch it for a little while longer and make sure that's the case. So, we get to, go ahead.
Oh, I was just going to say, I thought you were going to wrap up. So go ahead.
No, that was exactly right. Like, so, really what you start to see is these single-use applications communicating with each other really is 90% of the policies. Every once in a while you see multi-use applications, which are the ones you really want to watch, the stuff that can be used for good and bad stuff. And then that 10% overhead is really where you make sure that everything matches what you expect it to do. And if not, you have the chance to do some investigation work before you move it to enforcement.
Frank, just a note from our producers, if you would take down the screen, you could just see our two lovely faces chatting. Just makes for a better, yeah, there you go. Perfect. There we go. So Terry is asking the same question, sort of flipping it over and saying, what about false positives? Where, what happens where the policy engine mistakes a valid flow for a malware flow? How does that work?
So we don't, that doesn't usually happen. I won't say it never happens, but what you're going to see then is, once again, that simulation mode is really kind of the great equalizer. So we're going to simulate that traffic after they recommend the policy, and we're going to make incremental changes to the policy if we have to. But when you put it into simulate mode, what you're going to start seeing is, if it mistakes it for malware and leaves it out of a policy, you're going to start seeing block, right? And you're going to want to go look at, why am I seeing all these blocks? And it's going to lead you to, finding exactly what's talking to what and how. And that's really the great part, is we can see down to the application, so that, triage that you're doing happens very quickly. It's kind of, the system's almost like turning the lights on your data center, because you can literally see how every application is talking to every other application. So if you were, seeing a bunch of blocks, go in there in the GUI, within seconds, you'd be looking at what's being blocked and why. And then you might just ask a question to the app folks and say, hey, should this really be blocked? And they would say no, and then you adjust your policy.
So you basically whitelist it. Yep,
exactly. And we don't, like I said, you're not going to, over that 2 weeks of time, all of that stuff is going to get, the system's going to be like the canary in the coal mine, and this is going to get, resolved very quickly, which is why we're, so confident in as little as 2 weeks, we can, move to enforcement. I've done it, over and over again. So, from that perspective, the other thing I'd want to mention is, while I say 2 weeks, really most of the time it's about 2.5 hours of my time over that 2 weeks. It's not like I'm spending 80 hours doing that, right? It's literally just going in, checking it every a couple days, seeing if I'm close to getting to an effective policy. And when I am, I just go ahead and move it to enforcement. And the system can be watching all of your applications at once, right? So it can move as fast as I can. While I may only be looking at 5 or 10 applications, it's still watching all the other applications, preparing them to move them to segmentation. So it can move as fast as you can.
And I have a very detailed question from Larry. Does your agent make any use of eBPF in the Linux kernel?
Hey,
That was my reaction.
I'll have to go back and
yeah, Larry, if you can,
I'll have to go back and look at that.
If you want to kick another question over that elaborates on a little further, like why you're asking, that would be good. But honestly, I think you've won the prize for stumping us here. A couple other questions. You know, ZWS's verification of the first packet in the flow would work well for TCP, but what about UDP? You know, what happens when you've got real-time video, voice, and I'm going to highlight a bedside monitor that's sending data because there's another question coming up that refers to that bedside monitor. So how do you handle UDP?
Yeah. So today, to be honest, most people don't want to enforce things like video and you know, type of traffic like that. And as a matter of fact, most like, you know, I know Call Manager, but most IP telephony systems and video systems really probably wouldn't even support the agent running on it because, you know, when you start affecting latency and maybe even the, you know, any order of the packets or anything with broadband type communications, and you're causing problems. So those probably wouldn't be good candidates in the first place. But in that case, right, many of the UDP systems actually use a TCP control channel, and so we can control that. But anything that's pure UDP today, we don't apply security to.
Okay, so short answer is we don't do that. And speaking of that bedside monitor, can ZTIDs be shared from one customer to another? Say a bedside monitor that's sending data to a nurse station app.
Yeah. So we don't expose one customer's fingerprints to another today at all. We can actually learn the fingerprints per customer very quickly, so there's not a lot of benefit for sharing those back and forth from that perspective. The one thing I want to be clear on is that normally with IoT type devices, we're not going to be able to install an agent. So at that point, what we do is we create a object that we represent those bedside monitors, for instance, and then on the application side, on the server side, we can control which devices they're allowed to talk to and specifically which process they're allowed to talk to. So you could be sure that those bedside monitors would only be able to talk to the correct application in the correct servers. But you know, without some additional products, for instance, from Zscaler, they could still, you know, a bedside monitor would still be able to talk to another bedside monitor because we're not controlling that because we wouldn't have an agent on it. So we can control, you know, the applications they talk to or the applications that talk to them, but we're not, ZWS is not a solution for the campus, I guess is what I'm trying to say.
Got it. And sort of doubling on that though, question, how do you ensure that the model you're building of the bedside monitor, since you can't install an agent on it, how do you ensure that that model is actually associated with the right bedside monitor? Because I can see a hack where you come in and, you know, put something else in there.
Yeah, definitely we'd have to integrate some other systems. A lot of times we'll take exports from IPAM or some other type of IP address management system or things like that. When we'll usually automate that through the API. So, you know, from that perspective, we'd say, you know, this IP address equals this bedside monitor through another system. We would update our network object, right? If that was changed, we'd have to update that. But then we're tying that, you know, IP address or group of IP addresses to allow it to access certain applications and only those applications. You know, so from that perspective, we're doing everything we can on the application side, but we don't, you know, we don't control the campus side of the house.
Okay. And a couple more questions. Do you have any best practices documentation on how to deploy and operate ZTP? And in particular, informing an organization about changes that will need to be made about existing processes, changes made to existing processes to employ best practices. In other words, how we've talked about the technology. Now let's talk about the people process. How do you deal with that?
Yeah, absolutely. So we certainly do have best practices around that. We also provide services around that, and our partners provide services as well. But we do have a lot of times, if you're interested in ZWS and you engage us on that, we'll have things like architecture workshops. We'll go over those best practices, and a lot of times it's a multiple team approach. Like a lot of times it's security team plus network team. There may be other teams in there as well. And we talk about, what that end-to-end zero trust architecture looks like. Maybe today you're just going to use ZWS to concentrate on the data center. Maybe you're going to use something like ZPA and ZWS to safeguard all the way from your, end users, assessing who they are, what their role is, what their posture is, and then finishing that, with ZWS in the data center to make sure they can only access the correct applications. But you could certainly send a note out, and we would be able to help you with any type of architecture documentation that we have available, or we can engage your Zscaler team and kind of have that those meetings ad hoc.
Okay. And last question really has to do with, you've highlighted briefly the core of the technology, which is also the core of the discussion here, which is that fingerprint / identity that's 31 parameters. Yeah. Can you talk a little bit more about what types of parameters they are? I mean, I understand that some of this is special sauce. You may not want to share everything, but at least to get an idea of how you create a relatively solid fingerprint base, because there's actual physical fingerprints, then there's DNA. So like, how do you, what are the parameters you look at?
There's a lot of different things. So, some of it depends on if it's a Windows workload or a Linux workload. They have different parameters that we look at. But, there's things like the digital signer, PE header, size of the file, hash of the file, name of the file, directory it's installed in. Is it containerized? Is there a container ID associated with it? What machine is it on? Which, some of these have higher priority than others, right? Some specific machine parameters. But yeah, I don't know if I've seen all 31 of them. But certainly, they all kind of come together and are compared. And some of them are some of them are things that we generate as well, right? So a lot of people think that we take these fingerprints and compare them to, for instance, the government NIST RDS database, which has all the MD5 hashes for, and say, oh, this is Microsoft Exchange. We don't actually do that because there's a lot of custom software out there too. So what we're doing is creating kind of locally significant to us fingerprints. And then, we're doing that for each customer and each application. And then, that's what we're using to build our policies and different things with. So, it's something that we generate in some cases, and there's some things that we get directly from the applications themselves based on the information that's provided. And then all of that ties together to make up those 31 attributes, and those are compared on a connection to connection basis.
Yeah, no, and I love the story about, the guys that came in and started to create applications on the fly. I was like, that's actually pretty sharp. And what was interesting was you guys looked at it and you said, no policy equals you're not doing anything. So it's like if you're missing, if your attributes don't line up, or we don't have a policy for you because we never saw you before, you're not doing anything, even if you're benign. That's when we call mom.
Right. And that's the big difference, to be honest, is that it's such a Herculean effort to manage these firewall policies,
right?
That a lot of times they don't want them to change, right? They analyze them once and they want them to stay in place as long as possible until they have to change them because it's so hard to keep them up to date. And so with us, we're literally checking that security, every time because, we're going off of that identity. So, the point where we're always looking back at the application to say, are you still this application? Are you still this application? A firewall can't really do that because, it doesn't really know what the application is, first of all.
You're coming from this port, you're this IP address, we got you. Yeah. No,
Yeah,
I
and
think
to
that,
update those policies is crazy. Yeah.
and that's actually a huge practical implication here that hopefully people have picked up, which is this idea that you can airlift on the solution over your existing firewalls. Don't have to change them, not going to break them. Everything you've already done will be preserved, although in theory you could begin taking them away, because in theory this would, obviate the need for a lot of the
Well,
firewalls, but you don't have to. You can leave everything perfect, so you don't have to let go of the guardrails here.
yeah, and I don't want anybody to misunderstand. It's not like we hate firewalls, right?
Yeah.
It's just that firewalls are an expensive resource, and they do things that aren't required for every different type of connection, right? You don't always need layer 4 through 7 inspection for your backup traffic, right? So let's offload what we can to something like ZWS. Let's use the firewalls for what they're intended for, and you get the best of both worlds. You get that high level inspection when you need it. You get high performance and the right level of security east to west when you don't have to involve the firewall, and you get things, for instance, like a server sitting next to a server on the same virtual host, or a server sitting next to a server on the same VLAN. You still get the security you need. We can even secure an application talking to another application that's sitting on the same server.
Right.
So
because the container you're in is actually part of your ID, so you can differentiate
right.
between them. So
Right.
Well, believe it or not, we are like 2 minutes away from the hour. So that time flies when you're having fun, right? Thank you for your presentation, Frank. And thanks to everyone for the great questions. If this discussion has piqued your interest, please check the links in the chat for further information from Zscaler, including documentation and assistance for making those changes and those transformations. Thanks, Frank.
Yep, thank you.